All right, in this video, let's do some scientific notation. We're just going to work on the basics in this video. And so when we see this first example, this 465, know that that is written in what we call standard notation. It's just a straight number. We just have an integer here, 465. But how would we write that in scientific notation? Let me just show you, and then I'll back up and explain some of the rules. That's going to be 4.65 times 10 to the second power. And so the reason we would do this, let's just say this at the beginning. Scientific notation allows us to express extremely large numbers or extremely small numbers in a reasonable format. And 465 is not a large number. No one has a problem writing 465. But it's a convenient number to help us illustrate what we do with scientific notation. And you'll want to see this. Notice the decimal. It is to the right of the first non-zero digit. Let me repeat that. In proper scientific notation, the decimal belongs right here to the right of the first non-zero digit. 46.5 times 10 is true. If you multiply 46.5 times 10, you're going to get 465. But that would not be proper. And that's the key word, proper scientific notation. And we're multiplying it times 10 to the 2. Now 10 to the 2 is 100, right? Okay? And so we know if we multiply 4.65 times 10, 10 squared is 100, 10 times 10, we're going to move the decimal 2 places to the right. And that gets us back to our original number of 465. So let's try to do a couple more examples here. What about 4,305? Notice where the decimal is located in the original number. Now this is standard notation, but the decimal is right there. Now where does it belong in scientific notation? It belongs to the right of the first non-zero digit. So an easy way to do that is just to do your little waves or whatever you want to call them and move it from where it currently is to where it should be for proper scientific notation. So that would be 4.305. But we can't leave it this way because 4,305 does not equal 4.305. We need a times 10. We need a factor to multiply this by, and that would be times 10 to the third. Now, why is it a positive 3? Because we need the positive to go to the right 3 places to get back to its original location or to its location in standard notation. What about our next example with 0.0065? So we've got a small number here, and we can see our decimal, it's right there. But again, in proper scientific notation, where does the decimal belong? To the right of the first non-zero digit. Don't lose track of that key word. So it's going to go to the right of the 6. So this would be 6.5 times 10 to the negative third. Now wait a minute. We did positive in our first example, but negative in this one. And that's because the reason it's negative is because it has to go to the left to get back to its original number, its position in standard notation. So this negative right there tells you this decimal has to go to the left to get back to its original location. In this case, it would have to go 1, 2, 3, right? So 1, 2, 3 to get back to 0.0065. But in this example, to get back to 4,305, it's got to go 3 places to the right. All right, now what about going from scientific notation to standard notation? I've given you a number 6.07 times 10 to the third. Well, that's a positive, isn't it? Even though we don't write it. And that means the decimal has to go to the right. So 1, 2, I got to go 1 more to the 3, so that's going to be 6, 0, 7, and then 1 more, the decimal is going to be right there. That's 6,070, okay? That's 6,070. What about this one? It's negative. That means it's got to go to the left. Right? You need to pay attention to these arrows. Negative means the decimal has to go to the left. And so in this case, we're going to say we've got 607. All of those are significant digits, which is a later unit. But it needs to go to the left. It's right here. So there's 1. So I've got to have 2 zeros. Okay, boom, right there. 2, 3. So this number right here in standard notation is 0.00607. All right, guys, those are the basics of scientific notation.